Welcome back to Talk Tensors. You know, our cities sometimes feel like one giant traffic jam, right?
Yeah, it can be a bit overwhelming.
Especially during rush hour. But what if there was a way to make all those cars and buses move smoothly, like a perfectly choreographed dance?
That would be amazing.
Well, that's the vision behind CoDriveVLM. VLM enhanced urban cooperative dispatching and motion planning for future autonomous mobility on-demand systems.
That's a mouthful.
It is, but the concept is pretty simple. Using AI to manage fleets of self-driving cars, what they call AMON systems, to make transportation in busy cities more efficient.
So basically, robotaxis, but on a much larger scale.
Exactly. And this paper explores how to make those robotaxis work together, not just individually, to avoid creating even worse traffic jams.
Right, because having a bunch of self-driving cars doesn't automatically solve the problem of congestion. They could actually make it worse if they're not coordinated.
That's where CoDriveVLM comes in. It's all about cooperation, getting those cars to work together seamlessly. And the key to that is this thing called a VLM, or Vision Language Model.
VLMs are a pretty hot topic in AI right now. They can analyze images and text, like looking at a map and reading a report at the same time.
So it's like giving the AI eyes and a brain to understand what's happening in the city.
Exactly. It uses something called a bird's eye view, or BE image. It's like a simplified map that shows the AI where all the cars and passengers are.
Ah, so it's like the AI is watching over the city from above, like an air traffic controller, but for cars.
Kind of. But it's also getting real-time updates about traffic conditions, passenger locations, and all sorts of other data that helps it make smart decisions.
Okay, so let's say I need a ride. How does this AI figure out which car should pick me up?
Well, that's the dispatching part of the equation. CoDriveVLM uses the VLM and something called chain of thought reasoning. It's like forcing the AI to think step by step, like a human would,
Yeah.
to figure out the most efficient way to assign rides.
So it's not just blindly sending the closest car. It's actually considering a bunch of factors.
Exactly. It's trying to optimize the entire system, not just individual rides. It takes into account things like traffic patterns, passenger waiting times, and even the overall flow of traffic.
So it's thinking about the big picture, not just my little trip across town.
Exactly. But once those cars are assigned, they need to move safely and avoid crashing into each other. That's where the motion planning comes in.
Right, because you don't want all those robo-taxis turning into a pileup.
Exactly. So they use this really cool optimization algorithm called ADMM. It's like a continuous negotiation happening between all the cars in a certain area.
Negotiation. So are the cars actually talking to each other?
In a way, yeah, they're constantly sharing information about their positions, their speeds, their planned trajectories, all to avoid collisions and keep things moving smoothly.
It's like they have their own little language, a way of communicating to avoid turning the city into a bumper car arena.
That's a great way to put it. But I imagine trying to manage all these cars across an entire city would get pretty overwhelming. How does the AI handle that?
Right, it would be like trying to solve one giant puzzle.
Exactly. That's why they break it down into smaller, more manageable pieces. They group cars into what they call subgraphs based on their proximity and potential for conflict.
So instead of trying to control every car in the city at once, it's focusing on smaller groups of cars that are more likely to interact.
Exactly. And guess what? The same VLM that's assigning rides also helps to define these subgraphs.
So it's multitasking on a whole new level. Pretty impressive.
Yeah.
But it makes me wonder, are there any limitations to this approach?
Of course, no system is perfect, right? And the real world is always going to throw you curveballs.
Like what?
Well, think about unexpected road closures, pedestrians darting into traffic, or sudden downpours. The AI needs to be able to handle those kinds of surprises.
It's true. You can't predict everything that might happen out there on the roads.
Right. And there are other things to consider, like passenger comfort. Are we just going to be crammed into these robo-taxis, or will the AI prioritize a more enjoyable ride?
Those are good questions.
Yeah.
And that's what we'll be exploring in the next part of our deep dive.
I'm looking forward to it. You know, it's amazing to think about how we've gone from horse-drawn carriages to self-driving cars in just a couple of centuries.
It really is a huge leap, isn't it?
It makes you wonder what transportation will be like in another 100 years.
Flying cars, maybe? Teleportation, who knows?
Right. But to understand where we might be going, it's helpful to look back at where we've been. Like, how did we even get to the point where we're talking about AI managing our city's traffic?
That's a good question. Where did this whole idea of, using AI in transportation begin?
Well, some of the earliest attempts were pretty basic. Think about those early GPS systems, the ones that would sometimes send you on these crazy detours.
Oh, I remember those. You'd end up on some tiny back road, wondering if you'd ever find your way back to civilization.
Exactly. Those systems were using pre-programmed maps and algorithms, not really AI as we know it today.
So they were more like digital maps than intelligent systems.
Yeah, pretty much. But they were a starting point. They showed that computers could play a role in helping us navigate and make decisions about transportation.
So how did we go from those simple systems to something as complex as CoDriveVLM?
A few key things happened. First, computing power increased dramatically, which meant we could run much more complex algorithms in real time.
That makes sense. You need a lot of processing power to handle all that data and make decisions on the fly.
Right. And second, we started collecting vast amounts of data about traffic patterns, road conditions, even driver behavior.
It's true. Our world is swimming in data these days. Our smartphones, our cars, our cities, everything's collecting information.
Exactly. And that data is like gold for AI systems. It allows them to learn and adapt to make much more sophisticated predictions and decisions than those early GPS systems ever could.
So in a way, those early systems were like the training wheels for the AI, helping it learn the ropes of transportation.
That's a great analogy. And as the AI got smarter, researchers started tackling bigger challenges, like managing entire fleets of vehicles, not just individual cars.
And that brings us back to CoDriveVLM, which is all about making those AMON systems work smoothly and efficiently in a complex urban environment.
Precisely. And what makes CoDriveVLM so innovative is that it combines several cutting-edge AI techniques. The VLM's ability to understand both images and text is crucial for processing all that real-time data. And then there's the chain of thought reasoning, which makes the AI's decision-making process more transparent.
It's fascinating how all these pieces fit together. But even with all these advancements, I'm sure there are still challenges to overcome. You mentioned earlier that CoDriveVLM relies on having accurate maps and reliable communication between vehicles. What other potential problems do you see?
Well, one big one is the reliance on technology. What happens if there's a power outage or a network failure?
Right, the whole system could grind to a halt.
Exactly. These systems need to be robust enough to handle those kinds of disruptions. And then there's a human element. People can be unpredictable, and AI systems need to be able to anticipate and react to unexpected behavior.
It's true, you can't program for every crazy thing a driver might do.
Right, so we need to be cautious and test these systems thoroughly in real-world conditions before we start relying on them completely.
Safety has to be the top priority, absolutely. But even if we solve all the technical challenges, there are bigger societal implications to consider, right? Like, how will AI-powered transportation systems affect jobs and privacy?
Those are big questions. Like, with any disruptive technology, there will be winners and losers. Some jobs will inevitably be lost, but new ones will emerge.
That's always the case, isn't it?
And then there's privacy. These systems collect a ton of data about our movements, so we need to think carefully about how that information is used and protected.
It's a bit unnerving to think that an AI could know where you've been, where you're going, even how long you spend at each location.
It definitely raises some concerns. And there's also the question of control. As AI systems become more sophisticated, are we becoming too reliant on them?
Are we giving up too much of our own decision-making power?
Exactly. If an AI is telling you the best route to take, the best time to leave, even the best coffee to buy, are you really making your own choices? Or are you just following the algorithm's instructions?
It's a bit of a philosophical dilemma, isn't it? But it's definitely something we need to think about as we move further into this AI-driven world.
Absolutely. We need to find the right balance between leveraging the power of AI and preserving our own human autonomy.
Well, we've covered a lot of ground today, haven't we? We've delved into the technical workings of CoDriveVLM, explored the historical evolution of AI in transportation, and even touched on some pretty profound societal and ethical implications.
It's been a great conversation. I always enjoy these deep dives into the complexities of AI.
Me too. And, it makes you wonder, if AI can already do all of this, what will the future hold?
It's exciting to think about, isn't it?
It is. But before we get too carried away with speculation, I think it's time to shift gears and explore the ethical dimensions of this technology a bit further. Because as cool as all this sounds, there are definitely some thorny issues we need to grapple with.
You're absolutely right. The ethical implications of AI are just as important as the technical ones. So let's dive into that.
So we've talked about the technical side of CoDriveVLM and the potential impact it could have on society.
Right.
But there's another layer to all of this,
Yeah,
the ethical side. Like you mentioned earlier that the system relies on a ton of data.
it does.
Passenger locations, traffic patterns,
Mhm.
maybe even personal preferences, like if someone always requests a certain route.
Right.
That brings up some serious privacy concerns.
It does. I mean, if an AI knows where you're going, how often you travel, even like you said, what kind of coffee you like to pick up on your way to work,
Yeah,
that's a lot of personal information.
it is.
And we need to be very careful about how that data is collected, stored, and used.
Absolutely. Like who has access to it?
Right.
Can it be sold to third parties?
Mhm.
These are questions we need to think about. And it's not just about protecting individual privacy either. There are also concerns about fairness and equity. Like, let's say CoDriveVLM becomes the main transportation system in a city.
Okay.
How do we make sure it serves everyone equally?
That's a really good point.
What if the AI, based on its data analysis, starts to favor certain neighborhoods or demographics over others?
Yeah, we definitely don't want that to happen.
Right. So we need to make sure these systems are designed and implemented in a way that benefits everyone, not just a select few.
Absolutely. It's like building a new public utility.
Oh, I like that.
But instead of water or electricity, it's transportation.
Right.
And we need to make sure it's accessible and affordable for everyone.
Exactly. And just like with any public utility, there needs to be transparency,
Yes.
accountability. People need to understand how these systems work,
Mhm.
how decisions are being made, and who's ultimately responsible if something goes wrong.
Absolutely. Transparency and accountability are essential. And then there's the question of control.
Yeah, you mentioned that earlier. Like, are we becoming too reliant on these AI systems?
Right. I mean, if an AI is telling you the best route to take, the best time to leave, even the best coffee to buy, are you still really making your own choices?
It's a scary thought, isn't it? Like, are we just becoming puppets of the algorithm?
It's a valid concern. We need to find a balance between using AI to improve our lives and maintaining our own human autonomy.
Well said. It sounds like we've got a lot to think about as we move further into this world of AI-powered transportation.
We do.
It's exciting,
It is.
but it's also a bit daunting.
Definitely.
Well, I want to thank you for joining me today for this deep dive into CoDriveVLM.
It was my pleasure.
It's been a fascinating conversation. And to all our listeners out there, if you want to explore more about the world of AI and machine learning,
Please.
be sure to subscribe to Talk Tensors for more deep dives. Until next time.